Chapter 5 is solving systems of linear equations, and the first section is solving those equations by graphing. So there's a number of different methods we can use, but this section is just about the graphing method. Okay. So first off, a system of linear equations just means we have two or more equations in the same plane. So for most of these problems, we're going to have two equations, but you could have 3 or 4 or 5 equations as well. Okay. And the solution is going to be an xy pair that satisfies, in this case, it's going to be both equations because there's only two, but if we had more than two, it would be all of them. So it's going to be an xy pair that satisfies all equations in the system. Okay. So on these first problems, we have a system here, and we have an ordered pair, and we're asked whether if the ordered pair is a solution to the system. So that means that this xy pair should satisfy both equations. So I'm going to plug 1 in for x into this first equation, and I'm substituting -2 in for y, and then I'm going to see if this actually balances out when I do the math. So I've got 2 minus 2 equals 0. That's true, because then 0 equals 0, so that works out there. But I don't want to assume yet that this is a solution for the whole system. I still have to test it out in the second equation. So when I substitute, I'm going to use parentheses, as that will help with the order of operations. Okay, so now I'm going to start simplifying. 2 times -2 is -4. And then when I combine those, I've got -5 equals +5. Well, that's not true. -5 does not equal +5. So it fails with this equation. So that means that no, that is not a solution to the system. All right. Okay, so let's try again over here. I'm going to plug in this xy pair into both equations. So 4 for y and 1 for x. Make sure you get them in the right slots. And then when I simplify here, I've got 3 plus 1 on the right side. So, okay, it works with that equation. Let's try 4 for y and 1 for x over here. And on the right side, I've had -1 plus 5, that would be 4. So this works with both equations, and that means that, yes, this is a solution to this system. Okay, let's talk about what this system would look like if we graphed it. We're not asked to graph it here, but if we did graph both of these equations, they would both be straight lines. Okay, so this one would have a slope of 1 and y-intercept of 1 and a slope of 3, and the other one would have a y-intercept of 5 and a slope of -1. So you're going to get two straight lines that intersect, and they're going to intersect at the point 1, 4. So that suggests how we could solve this system. Here we knew the solution to start, or the possible solution. But if we didn't know that solution, we could take both of these lines, graph them, and then find the intersection. And that's really what the graphing method is. Okay, so we're going to graph each equation on the same grid, and then we're going to find the intersection. And then you can test your answer as well. Okay, so here, let's try this out. I'll do a little color coding with this one. So I'll do this in blue pen. So I'm looking at this equation and thinking, oh, this is already in y equals mx plus b form, which is really nice for graphing because I can see the m is what's in front of the x, so that's 1. And since I'm going to be thinking that as rise over run, I'll think of that as 1 over 1. All right, and then the b part is -2, and that's my y-intercept. So to graph this, I'll start with that y-intercept at -2, and then I'm going to use the slope to get to a second point. So I'm going to go up 1 to the right 1 from my point, not from the origin, from the point I already know. So up 1 to the right 1 puts me right there, and I can go up 1 to the right 1 again and again and again. And for these graphing problems, I like to plot as many points as I can. So I'm also going to go down 1 to the left 1, because -1 over -1 would also equal +1, right? So I can go down 1 to the left 1. Okay, and there's what my first line is going to look like. And even if you didn't have a ruler, you could make a really nice graph with all of those points. So there's my first line, okay? The second line, I'll do this one in red just to color code it. So my slope here is -1, and you could think of that as -1 over 1, or you could think of it as +1 over -1. So either way, you could do rise over run like that. Okay, and then my y-intercept is 4. Okay, so that's where it crosses the y-axis, and then from there, I'm going to go down 1 to the right 1, and I'll keep going down 1 to the right 1. And the more points you plot, the better, because hopefully First off, it helps you to draw a nice straight line, but also hopefully you'll plot the same point twice. Like I plotted this point when I was plotting the blue line, and I'm also plotted it when I'm plotting the red line. So I know for sure that, assuming I graph these correctly, I know for sure that this point is on both lines, and that's going to be my solution. So this is the point 3, 1. So you can just state your solution as an ordered pair like that, or you could say x equals 3 and y equals 1. That would be fine too. Okay. The third step in my is to check this xy pair. Okay. So the way you would do that is by plugging 3, 1 into both equations and making sure it works, just like these problems. Okay. I'm going to skip that step just in the interest of time, but you can always test your answers. This xy pair should work in both of those equations. Okay. All right, so let's try another one. This second one's a little bit harder because these equations aren't in y equals mx plus b form. So there's a couple of ways you can do this. You could find the x and y intercepts and graph that way. But what I'm going to do is put these in y equals mx plus b form. Okay, so I'm going to take this equation. I'll use this space up here. And I'm going to rearrange it so that the y is isolated. So I'm going to first subtract x from both sides. Okay, you could write the right side as 8 minus x, but I don't want to do that. I want to slip the negative x in front of the 8 because I want to get it closer to y equals mx plus b form. So I want the x part to come next after the equal sign. Okay, and then y is almost isolated, so to isolate y, I'm going to have to divide everything by 2, the whole equation, all 3 terms. Okay, and yeah, you could write this as negative x over 2, but I'm going to think of it as negative 1/2 x. And then I've got plus 4, okay? Because now I can see the slope and the y-intercept. So my slope would be negative 1/2. And you could think of that as negative 1 over 2 or 1 over negative 2. I kind of like to assign the negative sign either to the top or bottom to make it easier to read for graphing purposes. And then my y-intercept is going to be 4, okay? So let's go ahead and plot that. Here's the point 4, that's my y-intercept, and then I'm going to use this form. I'm going to go down 1 to the right 2 from there. Down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, or I could go up 1 to the left 2, up 1 to the left 2, up 1 to the left 2. And now I've got all the points that I can fit, the nice integer points I can fit on this provided graph. Okay. All right, so let's try the same thing with the other line. I'll do this one in red. I'm going to use the space at the bottom here. So the first thing I'd want to do is subtract 3x from both sides to start to isolate the y. So, okay, so I'd be left with just the negative 2y on the left. And I'm going to slip the negative 3x in front of the 8. Okay, and then I will divide everything by negative 2 to isolate the y. So now I have y equals, and negative over a negative would be positive, so this would be y equals 3/2 x minus 4. Okay, so now I can see that my slope here is going to be 3/2, and my y-intercept is negative 4. Okay, so let's go to negative 4 on the y-axis, and then from there I'm going to be going up 3 to the right 2, up 3 to the right 2, up 3 to the right 2, up 3 to the right 2. Okay, and now let's graph this line, and I can see the intersection. It's a point that I graphed for both of these lines, so this would be the point 4, 2, and that is my solution. Okay. So this method works really well under certain circumstances. It works well when you have a nice integer intersection. Sometimes your intersection might be a decimal or a fraction, and it's a lot harder to tell exactly where the intersection would be. Also, you know, if I had an intersection that uses large numbers, then it wouldn't be very convenient because I'd need a really large graph. So this is nice for these simpler problems that have intersections pretty close to the origin and where the intersections are integers. Okay. On the next page, let's try a word problem. Okay, so you have a total of 18 math and science problems for homework. You have 6 more math problems than science problems. How many problems do you have in each subject? So X is going to be the number of math problems and Y will be the number of science problems. So we got to write some equations first. And the first equation I'm going to write is just from this very first part. I have a total of 18 math and science problems. So if this is my X and this is my Y, well then I can say X plus Y is going to equal 18, right? So there's an equation right there. X plus Y equals 18. So that's an equation for my total amount of problems, okay? Then it has this other part where it talks about I have 6 more math problems than science problems. Okay, so 6 more X's than Y's, right? So what I can do, I can take, I'm thinking, which one do I have more of? I have more math problems. So I could take the math problems and subtract 6, and that would equal the science problems. Or I could take the science problems and add 6 to it. Either way. So let's say I'm going to take my math problems. That's the one I have less of, so I'd have to add 6 to that. So say I had 10 math problems, I'd add 6, and that means I would have 16 math problems, right? So you can imagine you could also have X minus 6 equals Y if you subtracted 6 from both sides. That would work too, okay? So now I've got my 2 equations, okay? So I'm going to solve this by graphing. I want to graph both of these, so I want them both in Y equals mx plus b form. So what I'm going to do here is subtract x from both sides to get y by itself. And I'm going to put the negative x in front of the 18 so that it's closer to y equals mx plus b. So now I can see that my slope is negative 1, which I can think of that in either of these ways. And then my y-intercept is going to be 18. Okay? So let's go ahead and graph that one. Okay, so let's see, y equals 18, hey, just fits, right? There's my y-intercept, and then I'm going to go down 1 to the right 1 from there. And it's a little tedious, but I'm going to just put every point in there so it makes it easier to find the intersection when I have both lines graphed. Okay, got my first line here. And here, let me color code this. I'll start doing this one in red here. So to get this one in y equals mx plus b, I want to subtract 6 from both sides. And then I have y equals x minus 6. Okay, so my slope would be 1 or 1 over 1. Or I could do negative 1 over negative 1 if I wanted. And then the y-intercept is negative 6. Okay, so that's going to just fit on the provided graph as well. There's my y-intercept, and I'm going to be going up 1 to the right 1 from there. Up 1 to the right 1, climbing all the way up the ladder. And let's see. Messed a little bit there, but it's good enough. Okay, so then I can see my intersection here, and then I'm just looking, what point is that? That's the point 12, 6. Okay, that's my intersection. So now I just want to interpret, well, what does that mean? Well, that means you got to go back and look, what were your x's? So your x's are the math problems. So that means we're going to have 12 math problems and 6 science problems, because the science problems are the y. So let's go ahead and write it that way. So 12 math problems. It says how many of each do we have? And 6 science problems. Okay, and you can check it with both of the equations. We have a total of 18 problems, so it works with that, right? And then we have 6 more math problems than science problems. Well, that works out that way too, all right? So there's our solution, and there is the end of the section, and I'll see you next time.